Hi, my name is Renato Lopez. This is my student ID, and this is my circuit. So my circuit, the main function is electronic dice. So how it works is basically I emit a low pulse into the 4017 IC, and this low pulse from my finger makes it shuffle, and then when I release my finger, it locks into a specific number, just like a dice. And I have my secondary function, that is the potentiometer. So this potentiometer, when I move it, it controls the intensity of the LED of the dice. And I have another secondary function, which is the light here. This light is an indicator that the circuit is powered, and is completely independent from the potentiometer. So you can see now it's locked in 2. So when I touch, it shuffles and then it locks into a specific number. And when I move the potentiometer, I can control the lights of the LEDs, completely independent from the indicator light here. Alright, so this is my circuit. As you can see here in the middle, you have the 4017 IC. And from the 4017 IC, the current goes and passes through the resistors, the diodes, and then into my LEDs. And from the other pins, it passes through our resistors and directly to my LEDs. Up here, you can see the internal circuit of the 4017. In pin 14, that's basically where I touch the wire, where I input my pulse, and 13 is always high. Therefore, the output will alternate in between high and low, and this pulse will be sent into the clock of the Johnson counters. The 4017 has 5 Johnson counters, and they're all related to each other. Therefore, every time you have a clock input, it fluctuates in between the high and low, and then when you release the clock pulse, it basically locks into a specific pattern on the outputs. And then from the Johnson counters, it goes into an AND gate again, and this AND gate also it changes in between high and low because it depends on the output of every counter. And from there, it goes all the way to the LEDs, passing through the resistors and diodes. Alright, now for the measurements, I'm going to measure the voltage drop across the resistor 3, and we're going to do the calculation of the range of currents across the LEDs. We have a voltage of 4.96 at pin 12 and 3.97. So 4.96 and 3.97. And then we're going to reduce the intensity of the light of the LEDs almost when it's turning off, just at the threshold, and we're gonna measure the voltage again. So at pin 12 is 2.25, across the resistor is 2.24, 2.25 and 2.24. The multimeter doesn't have the tolerance to measure milliamps, so I'm gonna have to calculate it. So 4.96 minus 3.97 over 100, it will give me 9.9 milliamps. 2.25 minus 2.24, it will give me 0.1 milliamps. Now we're gonna go to LT Spice and simulate it. Alright, at pin 12, I'm gonna start with the 4.96 as we measured before, and across my resistor I have a voltage of around 3.7, and my current across the resistor is of around 12.2 milliamps. And now if I change my voltage to 2.25, we have a very low amps, almost zero. So to compare the two values, these values differ due to a lot of factors. One of the factors are the multimeter that have different tolerances, and also in the circuit you have extra resistances due to the wires and stuff that can differ the values. Based on the measurements, we can safely say that the range of currents are in between 10 milliamps to 0.1 milliamps. That will be the operational current of my circuit, and that will be it for my project. Thank you.